10.2, evaluate and graph exponential function. So a lot of natural science, application problems will use this exponential functions on formulating and computational part. If you very fundamental one that you're gonna see right away in later in the sections are talk about the population growth and the chemical decays and the compounded interest, all of those, right? We'll see it in later session. So, what is exponential functions? Exponential functions is basically a functions formulating in this format, a to the x power. So, in exponential functions, the base is fixed number. The base a is a fixed number, and then the exponent is the one that is going to be vary. Base a has to be greater than 0. You cannot have a negative base, and a cannot be equal to 1. Okay? If a is equal to 1, because 1 to the any power is just 1, so it will be just a straight line. It's not going to do anything, or it's not going to be applicable in application problems. And another one that you want to look at is natural exponential functions. See, natural exponential functions is basically the same thing, but however, base is a specific base. And this time you can see that the base is what? E. And this natural exponential function is mostly used in the application growth and then continuous compound interest and stuff. So what does E represent? E is just a number, something like a pi, a decimal number never ending and never repeating. So here's a few decimal digits, decimal places that I wrote it down for you. E is 2.718281.827, and then so on and so forth, continuing. So what we want to do is we want to graph exponential function. So I'm going to show you a different base of exponential functions have a very similar shape of the curve, right? Similar shape of the graph. And then from there, we're going to use transformations to graph the other ones. So the very first graph that we're going to look at is f of x is equal to 2 to the x power. So as usual, if I want to graph this, I'm going to plot the points. So plotting -2, -1, 0, 1, 2. So if I plug in -2, that's basically f of -2. That tells me 2 to the -2 power. To compute -2 power, I need to change it into positive exponent by reciprocating it. And then that will become 1/4. And similarly, if you compute -1, that will become 2 to the -1 power, which is 1 over 2 to the 1 power, which is 1/2. 0, f of 0. So 2 to the 0 power, that is always what? Any number to the 0 power is always equal to 1. And then f of 1, which is 2 to the 1 power, that will be just 2. F of 2, that will be 2 to the 2nd power, which is going to be 4. And if you plug in 3, f of 3, that will be 2 to the 3rd power, which is 8. Notice that it shoot up a lot faster. So we don't need any more points. We can just use these to graph it. Okay. So on the right side of 0, if 0, it'll be, when x is 0, it'll be 1. So here's my point. When x is 1, my y will be 2. And when x is 2, my y will be 4. And when x is 3, my y will be 8. And when x is -1, my y will be half. And when x is -2, my y will be 1/4. So notice that once we go into left-hand side, the graph is getting closer and closer to this x-axis. Now, let me tell you this. Let's try to compute f of 100 when x is negative 100. That will be 2 to the negative 100, and then it will be 1 over 2 to the 100 power. And then if I use a calculator to compute this, that will be a very, very close to zero number, approximately. So try to use a calculator and calculate this 1 over 2 to the 100 power. So you will see that it's very, very close to zero. All right. So that what does that mean is, as you go into a negative, plug in a negative x value, your y value will be very, very small. But however, my y value will never become 0, because numerator is always 1 and it will never be 0. So that tells me the exponential graph are bounded by a line. So here's the exponential graph. On the right hand side, it will be keep on going up. And on the left hand side, it will be keep on going down, but however, it will be getting closer and closer and closer to zero, x-axis, but never touched it. Okay. So that bounded line is called the horizontal asymptote. In this case, our bounded line, right, the boundary line will be right here. So this boundary line is called horizontal asymptote. So it is a line, so that will be y equal to 0. This is the equation formula that we write down. For this, later on, the shortcut will be horizontal asymptote h of a. That's what I will write it down. So now you can see that the shape of the exponential graph when the base is 2. So let's explore on the next example when the base is 3. Okay, what is the difference? So when the base is 3, again, because of so we are exploring. So now I want to know my graph by plotting the points as usual. So when it's f of negative 2, that will become 3 to the negative 2 power, which is 1 over 3 to the second power, which is 1 over 9. F of negative 1, that will be 3 to the negative 1 power equal to 1 over 3 to the 1 power equal to 1/3. And f of 0, 3 to the 0, any base to the 0 power is always equal to 1. F of 1, 3 to the 1 power is equal to 3. F of 2, that will be 3 to the second power, which will be equal to 9. So notice that as I move on to x value to the right, and the y value goes up a lot faster than the previous one. Go back and check, right? So notice that right here, 0 is 1, the same, but 1 is 1, when x is 1, the previous one, because of base 2, it will be 2, right now it's 3. When the base, when x is 2, it will be 4, and right now it's 9. So notice that it's shooting up a lot faster on the right hand side, and as well as getting closer to x-axis a lot faster on the left hand side, because you can see that it will be 1/3 and then also what 1/9 the y values. So let's graph it again. At 0, when x is 0, it will be 1. When x is 1, y will be 3. When x is 2, my y will be 9. And when x is negative 1, it will be 1/3. And then when x is 2, it will be a 9, so very close to it. And again, similar idea, because when negative 100, f of 100, that will become 3 to the negative 100 power, right? 3 to the negative 100 power, which is going to be 1 over 3 to the 100 power. It will be very, very small number, but not 0. So as before, I will have a boundary line also, right? Which is the called horizontal asymptote. So you will see that it will be getting closer and closer, but not touch it. So as before, I will have a horizontal asymptote at this point at what? This y equal to 0 line. So horizontal asymptote y equal to 0. So all the exponential graph will have horizontal asymptote, and that is the one that will help you to see how the graph is going to be behaving, meaning it's like cannot pass through this line or below or above the line. Okay. So notice that even though the base is different, the shape is very similar. Okay. So now what you need to try is try this e to the x power. Right? You're gonna have to use a calculator to approximate it. So before we even go into any further, e is basically the base 2.7. We're gonna approximate with 2.7. Okay. So since the base, in this case, the base is 2.7, that must be, the graph of this must be between the first example and the second example graph, because the first example has base 2, the second example has base 3. This one is what? The base 2.7 something. So let's try to take a look at on this example. Okay. So as usual, I'm gonna substitute -2, -1, 0, 1, 2, and then round it to 1 decimal place. So that way I can, you know, graph better. So in your calculator, it should have a function key e to the x power. You should look at it. So first, you're gonna type it in. If your calculator shows everything that you type it in, then you're gonna press e to the x power first, and then you plug it in the exponent to get the answer. If your calculator doesn't show everything that you punch it in, then what you're gonna do is you're gonna punch in the exponent first, and then press e to the x power. So for this case, I'm gonna calculate e to the second power. That gives me approximately 7.4, only 1 decimal place. If e to the 1 power, that will be 2.7 approximation. E to the 0 power is 1. Okay. And then e to the -1 power, so we're gonna punch in a -1. And then e to the -1 power is 0.4 if I approximate it to 1. And then e to the -2 power, that will give me 0.1. So you have to use a calculator, okay, and then see you can get these value or not. Otherwise, that you're gonna have to ask me or ask a tutor to help you out with your calculator, okay, in the next class meeting. So we can graph it. At 0 will be 1, and at 1 will be 2.7, and at 2 will be 7.4, and -1 will be 0.4, and then -2 will be 0.1, which is very close now. So again, you can see that there is a horizontal asymptote that limit the graph. So here's my horizontal asymptote again. Horizontal asymptote y is equal to 0. You have to write it in equation format because these are aligned. And now I'm graphing my exponential graph. So this will be going up this sections and then going down. So notice that the shape of it is very similar. From these 3 examples so far, what I want to point out is the similarity. Okay. And if you go back and look at all of those XY chart, and these are the points that we can use and then sketch it quickly for the parent's graph. Now that we know the shape already, notice that for any base, when x is 0, my y will be 1. And when x is 1, the value will be the same as the base because, base to the 1 power is just that base value, 1. And then right here. With these 2 points, and remembering the shape of the graph, we can quickly sketch without plotting all these 5 points later on. Okay, that's one similarity that I pointed out to you so that you can graph it a lot faster later on, because later on what we're going to do is we're going to graph the parent's graph first and then do the transformation from that. So those 2 points will help us to make it a lot faster. Secondly, notice that all the horizontal asymptote so far is y equal to 0. Okay. So the question is when this horizontal asymptote will change. Only if the graph is shifting upward or downward, then the horizontal asymptote will also shift up and down. That's the only time that the horizontal asymptote will shift. Because if you shift left and right, the horizontal asymptote will not change at all. So that's something that you need to remember so that later on we can do this horizontal asymptote first so that I can graph my graph better and neater. So the next example is when the base is 1 over 4. Okay, when the base is 1 over 4. So let's try to look at when the base is a fraction less than 1, greater than 0, what kind of graph we're going to be getting. X and Y, like before, I'm going to plug it in -2, -1, 0, 1, 2, and then compute that. F of -2, that will be 1/4 to the -2 power. If I change it into positive exponent, that will become reciprocating the base, so it will be 1/4 become 4 to the 2 power, which will be 16. F of -1, that will become 1/4 to the -1 power, which is, when you reciprocate the base, that will become 4 to the 1 power, that will be equal to 4. F of 0, that will be 1/4 to the 0 power, which is equal to 1. F of 1, that will be 1/4 to the 1 power, which is equal to 1/4. And F of 2, that is equal to 1/4 to the second power, which is 1/4 times 1/4 is 1 over 16. So this gives me 16, 4, 1, 1/4, and 1 over 16. And how's that my graph going to look like? Notice that 0 is 1, and 1 is 1, it will be what? 1/4, same as the base. It didn't change. So at 0 will be 1. At 1 will be 1/4. And at 2 will be 1 over 16, which is very close to the x-axis again. And when you go to left-hand side, at -1 will be 4. And -2 will be 16 way up here. So notice that the graph basically what? Reflect about the y-axis. One is a fraction base that is less than 1. So my graph gonna be look like this. And again, the horizontal asymptote doesn't change in this case because it's bounded right here. Y equal to 0. So that's something that I want to point out, that if a fraction base that is less than 1, right? The base is less than 1, greater than 0, then the graph will be what? On the other side. So now, let's try to graph. Oh, before I graph continue, I want to point out something. Because because that will be helpful for us on the next sessions when we talk about the logarithms, because logarithms and exponentials are inverse of each other. So, from the 10.1, we know that inverse functions are basically what your domain and range flip around, right? Your x and your y flip around. So that's going to help us later on. So for this one, let's erase some. Let's write it down right here. My domain in this case is negative infinity to positive infinity, because the graph going to be extending to the left and extending to the right, and it will eventually cover the whole entire x-axis. But however, my range is going to be 0 to positive infinity. As you can see, the graph is never touches 0 or go down below 0 for the original one, right? For the parents one. So therefore, 0 is not even inclusive in this case. That's my range. Similarly, for the next x to the third power, my domain is negative infinity to positive infinity, and my range is 0 to positive infinity. For the exponential graph, the same thing. My domain is negative infinity to positive infinity. My range is 0 to positive infinity, because my y is going to be never 0 or negative number. And same thing, if your graph flip around, your domain will be negative infinity to positive infinity, but my range is going to be what? 0 to positive infinity. Now let's continue on the next graph, which is transformations. So we're gonna do the transformations right now, and try to pay attention on how I'm gonna graph my parents' graph quickly, and then do the transformations. So in this case, my parents' graph is y equal to 2 to the x power, which is nothing add subtract to it. And then the next will be y is equal to 2 to the, there's no reflections or stretching. So now I'm going to take care of the shifting up, down, and left, right. And notice that I'm subtracting x by 3. So that basically tells me it's going to be shifted to the right 3 units, okay, from the original graph. So how do I graph this original graph quickly, the parents' graph quickly? By remembering the 2 points that we talked about before and then the shape of the graph. The 2 points that we talked about before is when x is 0, it will be 1, and x is 1, that will be 2 to the 1 power, which is going to be 2. And then also remember the shape of the graph. So here's my parents' graph. At 0 will be a 1, and at 1 will be 2. And we know the shape of the graph is going like this, using those 2 points. Now the next question is, before I even continue doing the transformations, will my horizontal asymptote move? Since this graph is shifting right 3 units, my horizontal asymptote will not change from my original graph. So that means my horizontal asymptote for this functions is still going to be y equal to 0. So I know that my graph is bounded by this line again. And now I'm going to do the transformation, which is shifting my graph to the right 3 units. So this point, right, 0, 1 will shift to the right 3 units, so it will end up in right here. And 1, 2, when I shift it to the right 3 unit, it will end up right here. And I got my graph same shape as before. If I shift it to the right 3 units. And then bounded by this horizontal asymptote, so we know that we cannot pass it through this horizontal line. And that's how you can graph quickly on this exponential. Otherwise, you plug in the points one by one, like I said before, and then try to get the shape. Now, what is my domain in this case? Again, my domain is negative infinity to positive infinity because this is my graph, right? F of x. And my range, it will be also again 0 to positive infinity because it never touches 0 and there's no graph underneath of 0. Now, let's move on to the next one. See, hopefully you can, graph this. So what is my parent's graph in this case? That will be y equal to 3 to the x power. Nothing add, nothing subtract to it. There is no transformations in here, right? I mean like reflections or stretching, because I don't have any negative one in front of it like this, right? Negative in front of it, so there's no reflections. So what I'm going to do next is do the shifting. 3x to the plus 1 power. So you're adding 1 to x value. That means what? It's going to shift left and right. Since you're adding, it will be shift left 1 unit. And then lastly will be 3x plus 1 minus 4. And remember, this exponential part is equivalent of your y value. So right now you're talking about this exponential part is subtracted by 4. So the whole graph, you're sort of telling me that this is sort of telling you that your y value will be subtracted by 4. So it will be shift down 4 units. So to get the parent's graph fast like before, I'm going to try to plot the point my x and y, which is when x is 0, my y will be 1 because 3 to the 0 power is 1. When x is 1, my y will be 3 because 3 to the 1 power is 3. That will help me to get my parent's graph a lot quicker. So that means right here is 0, 1, and the next will be 1, 3. And then we know the shape of the graph, so it will be what? Going like this, a lot faster. So this is a sketch that we can. So originally my horizontal asymptote is right here, right? Y equal to 0. But this time, because of the graph gonna be shift down 4 units, the horizontal asymptote will also shift down 4 units. So I want to graph this horizontal asymptote first, so that way I will not pass, my final graph will not pass through this. So originally my horizontal asymptote is right here. Now it shifts down 4 units, so therefore my horizontal asymptote will become y equal to negative 4. So it will be this line right here. The graph cannot pass through this horizontal asymptote. Y equal to negative 4. So now let's do the transformation for my final graph. Point by point. This point first. This point 1, 0. First it's going to shift to the left 1 unit and then go down 4 units. So shift left 1 unit right here, go down 4 unit, 1, 2, 3, 4. So it ended up right here. Now the next point. This point. Shift to the left 1 unit, so it'll be right here, and then shift down 4 units, 1, 2, 3, 4. So it ended up right here. So now my final graph will be something like this. Going to the left, and then it doesn't pass through the horizontal asymptote, and then going to right up like this. So this will be my F graph. So now the question is, what is my domain? Again, the graph going to be extending to the left and right, and it will cover entire x-axis, so my domain will be negative infinity to positive infinity. What about my range? The graph's going to be continue going up, so it will cover up to positive infinity on my y part. But however, the graph never go below of negative 4, so it will be negative 4 to positive infinity, but negative 4 is not inclusive. And that is the graphing and also evaluating the exponential functions.